Hello, in this video I'm going to be going over atomic mass, which is the weighted average mass of the isotopes. And I'm going to start with an example problem of carbon. I have 3 isotopes of carbon listed here, and basically all of these carbon atoms, they have the same number of elements, which is why they're carbon. However, they have a different number of neutrons, which is why their mass numbers are different. Mass number being the sum of the protons and neutrons. So, we have percent abundance. The fact information doesn't really matter for finding atomic mass, but there's some interesting information. Carbon-14 used in radiocarbon dating for the age of various archaeological artifacts. Using NMR spectroscopies, carbon-13. If you take IB chemistry, we'll go into that more, but basically MRIs. Standard for AMU, carbon-12, is where we get our standard for atomic mass units, is the carbon-12 isotope. We have all these percent abundances, so I'm going to write percent abundance. I'm going to make a little chart. We're going to have percent abundance, relative abundance, and relative weight. And then I have my isotope mass. Carbon 12, 13, and 14. Alright, percentages. They give us 98.89, 1.1, and 0.001. So, when we look at a weighted average, we don't want to look at 100. We want to look at just 1. So our relative abundance is out of a total of 1, whereas our percent abundance is out of a total of 100. So basically we just need to divide all of these by 100, or we move the decimal 2 spots to the left, whichever way you prefer. One, two. We have our relative abundances. Once we do that, we take our isotope mass and we multiply it by our relative abundance. We do that by taking out our calculator that we bring to class each day. 12 times 0.9889 is 11.866. 1.1. Oops, 13 times 0.011 gives me 0.143. And I take 14 times 0.12341. 0.00014. So all I did was I multiplied my relative abundance by my isotope mass. Once I do that, I add up my 3 answers, and I'll get my atomic mass, which is my weighted average mass of all the isotopes. Right, and that's 12.00994 AMU, which is atomic mass units, and that is my atomic mass, which is my weighted average mass of the isotopes. I can then compare that to my actual carbon, which is 12, zoom up on that, 12.0107, which is slightly larger than the atomic mass that we found. The reason being is we only have 3 isotopes, but there's actually more isotopes of carbon than what exists on this chart. So there's carbon 15, 16, which would increase the overall atomic mass. Alright, I want to go over a real-life analogy of weighted averages. So here at OHS we have 20% of our grade is formative and 80% is summative. So this would be considered our isotope mass if we're creating this analogy. Alright, and then our percent abundance would be what you perform, or how you perform. Let's say we did pretty well on the test, about a 93 average, and then we had some missing assignments, so we have a 75% formative. We then find our relative abundance, and that's putting the whole out of 1 instead of out of 100, so we move our decimal 2 spots to the left of our percent abundance. This gives us 0.75 and 0.93. And then we want to find our relative weight, or our relative grade basically, by taking the relative abundance times the isotope mass. So we take 0.75 times 20, it's 15. 0.93 times 80 is 74.4. We then add up our two scores. 74.4 plus 15 is 89.4% would be your overall grade, which is just shy of an A-, which is why it's very important to turn all of your formative work in, preferably on time. So that's just kind of a real-life analogy of how weighted averages work. Isotopes work the same way.